Let's look at an application or two of what iterated integration can be used for. One is for calculating mass and center of mass. So let's say that we have a region R in the plane. And this can be vertically simple or horizontally simple. And suppose that at each point in R, we have a density. I'll represent that density as rho of x and y. Now in your physics classes, you may have done similar examples where you assumed that the density was constant. Here we're not going to make that assumption. So let's say that rho of x and y represents the density at the point x, y. Then mass, which we'll call m, is simply the integral over r of the density function with respect to area. Now when I write dA here, you can think of that as being either dx, dy, if you're working with something horizontally simple, or dy dx if it's something vertically simple. And the center of mass we can call x bar, y bar, is going to have coefficients, or sorry, it's going to have coordinates. X bar is 1 over the mass times the integral over r of x times the density. And the y coordinate of the center of mass is 1 over mass times the integral over r of y times the density. You might notice the similarity of that to the equations that we had for the center of mass of a curve with variable density.